This is the ROS Developers Podcast, episode 58. And this is a very special episode that we have recorded while at the ROSCon conference of 2019. So maybe you are going to hear a little bit more than usual background noise. And we apologize for that, but we thought that the people that were attending that conference was very, very interesting people. So then we took the chance to interview them during the conference. So you're going to see in the next 4 episodes is just about interviews that we have conducted while at the ROSCon 2019 to very important people of the ROS ecosystem. So I hope that you enjoy the interviews and that you can forgive us for the bad sound quality of due to the background noise. Just to let you know that we have some plans for improving this for the next conference. So big plans for that. So without more ado, let's go with the interview.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello ROS developers and welcome to the ROS Developers Podcast, the program, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate the episode to those ROS developers that have been using ROS for more than 10 years. Hey guys, you started in the difficult days of ROS, when ROS was just a seed, and then you kept pushing, and thanks to you that ROS is one of the things that has so much support at present. So thank you very much. This episode is dedicated to you. And today we are going to talk with a person who has been using ROS almost since the very beginning. Almost one of those amazing guys that were supporting the usage of ROS. And he also is even one of the members of Willow Garage when they were developing ROS. So amazing curriculum. But before going into that, let me remind you about our ROS Online Academy. Yes, that's the construct that we have created an online academy to learn ROS that is called the Robot Ignite Academy. It contains a ROS learning path for beginners, for example. Also for more advanced users, but we have created a specific learning path for beginners. We start by teaching you Linux and Python for robotics, and then we continue teaching you all the basics of ROS concepts required to become a master of ROS, a ROS developer. We conclude with a course that teaches you how to build your own robot and how to ROSify it, adding ROS control, and then you can finally become a ROS developer. I will put a link to the academy in the show notes. Actually, it's very simple, www.robotigniteacademy.com. So now it is my pleasure to introduce you with Michael Ferguson. Michael is the CTO and president of Botnuvo, a young robotics company that has just launched its first product. That's amazing. We have him here at the ROSCon. And Michael has started to work into ROS. He started to work into ROS in 2010 as a software engineer at Willow Garage. From there, he co-founded Unbounded Robotics, the precursor of Fetch Robotics. Then he moved to Fetch Robotics as CTO, and only recently he founded Botnuvo, a new company that builds robots for researchers, educators, and developers. Welcome to the podcast, Michael.
Thanks for having me here.
It's our pleasure. Amazing curriculum that you have in there. So then I'm really honored to have you here at the podcast because it's very difficult to get people with so much background in ROS, in the beginning of ROS. So how were the days at Willow Garage?
So I think, you said I've been working with ROS since really early on. I'm actually, I think, one of the first people that started using ROS who was outside of Willow Garage, right? Back in 2010, the people using ROS were either, Willow Garage employees or interns at Willow who took it back to their lab. And I'm one of those outliers. I actually first learned about ROS by going to RoboGames. Just this one time at RoboGames in San Francisco, Willow Garage decided to bring a PR2 up, and so they had the PR2 there. They were showing it off, and they were like, "Hey, this ROS thing, we just finished writing some documentation on the wiki. You should check it out." And I sort of went back to my lab at the University of Albany, and we started looking at how to use ROS, and was like, "Wow, this thing's really powerful." And so I very quickly converted our entire curriculum over to that. I was teaching our robotics course at that point at the University of Albany. And we were actually funded by a NSF grant that was the program no longer exists. The CPATH was like revitalization of computer science education. Okay. And we were trying to bring in people from outside traditional CS education, psychology majors and whatnot, right? To teach them some basics of how computers work and things like that. Obviously, that's a boring topic for most of them, so we were using robots, which was kind of cool. And so I really started to dive into using ROS and developing a lot of packages for ROS, and kind of got on the radar of the folks at Willow, and ended up getting to come out there and do an internship initially, and then actually join as a full-time software engineer.
Okay. Whoa, that's an amazing path you follow. That so starting from capturing your attention on that event, and then following the until you get in the inside. That's amazing story. Very nice. And then what were you doing specifically at Willow Garage?
So I actually did a whole bunch of different things. When I came in as an intern, it was very important that I have an intern project that was like specific of like what the deliverables were going to be. And that turned into ROS serial, right? So basically, the package, it's used everywhere out there. It's one of those things where like it's not my finest code because it was very early in my career, but it is still used all over the place.
And it's in the core of ROS.
It's how pretty much everybody connects like Arduinos and things to ROS, right? It lets you run a ROS bridge down to a small microcontroller.
You mean the ROS serial?
ROS serial. It was myself and I like to make sure I give credit where credit is due. It was myself and another intern as well, Adam Stambler, and so we basically co-developed that during the summer. We got it done really quickly, and so he continued building, all sorts of demonstrations on top of that. I ended up actually starting to work with the perception team, Gary Bradsky and Kirk Connellige, and Troy Strasheim and Ethan Rubley, Vincent Rabaud, right? This was the perception team at Willow, and so I started to work with them on a program that really never gained a huge following. It was called Ecto. And so, it's one of those things, most people have probably never heard of it. It kind of like disappeared into the ether because basically it became the foundation of industrial perception when they spun out. They used it as their framework internally to build these really great perception pipelines, when you're dealing with ROS, it's very nice in that you can connect all these different nodes together. You can have them, all running there. But if you try and build like a vision pipeline where like something starts and then it goes through a couple of nodes and kind of comes out the other end, you don't have any way to handle like resource allocation. And so that was what Ecto was trying to solve, was basically actually control schedulers so that you were focusing on throughput, not necessarily like you could get into a scenario where the first node basically consumes all your CPU. And it's running at 30 hertz, but nothing further down has got anything coming out. And so it was trying, in a lot of ways, ROS 2 and sort of the executors and whatnot kind of, I don't know that there's an executor today that solves that problem, but I think you now have the framework that allows you to solve that sort of problem where we just never could with ROS 1.
Okay, and something inside the nodelets packages?
It was an alternative to nodelets in a lot of ways, right? And in a lot of ways, I think it was maybe a rebuttal of nodelets, but it was very specific just for vision folks. And so I worked on that for a while. And then Willow was starting to do a lot of trying to figure out what its next thing was going to be, right? ROS was out there, it was gaining steam, the PR2 was there, and now it was like, okay, what could we do that's, a commercial robot? And so when I actually first started as a full-time engineer, I was actually working on a lot of this needs finding and prototyping and trying to very quickly build robots that could do a task and see what people thought of them.
Okay.
And then we sort of got to a point where, okay, it was time to, the PR2 is nice, but it's big, it's heavy, it's a logistics nightmare to move around. And so we sort of formed a new, a lot of the hardware folks that had built the PR2 eventually went to Suitable Technologies doing the Beam, the telepresence robot. Yeah. And so we kind of rebooted, the second generation hardware team at Willow Garage. Melanie Wise was obviously the lead of that. I was basically leading the electrical and software design, and we sort of were putting a team together, which eventually built a platform called PlatformBot, which again, I think there's like one presentation out there that talks about it. That was like
no idea.
Yeah, there's one IEEE Spectrum. It was sort of I think it wasn't Robo Business, but it was one of their other conferences.
Oh, yeah. The side conference.
And so there was one talk about it, and then IEEE Spectrum talked about it. And if you go look at that, you can sort of see how that eventually became Unbounded Robotics, right? We spun out of Willow to basically take this design and refine it and turn it into, a commercially available product, which was basically, the UBR is in many ways the heavily cost reduced and very much improved version of the PR2, right? You've gone from $400,000 down to sort of a $35,000 sale price. Unfortunately, it never actually launched, right? Willow obviously, met its demise and took a few other of its spin-offs with it just because of, legal aspects and whatnot, which we won't get into a lot of details about. That was, I think in many ways that is still my favorite robot arm that I've worked with was the one that was on the UBR1.
Like what's the name again?
The UBR1.
But
from
the original, the one before.
The PlatformBot before it? Yeah, so the PlatformBot didn't actually have an arm on it, but the UBR1, those arms that we ended up building, I think is still my favorite arm. It was just... it had great controls. It had great feedback when you were like interacting with it. Unlike so many of the arms that you see around the hall here, right? They're UR5s and whatnot that have harmonic drives and they're not back drivable and they're if it runs into you it hurts and whatnot. The UBR was actually just a really nice robot for sort of working around.
I see. Yeah. Okay. What an interesting path. So so then finally, let me check about the questions that we have. And then I think that you already answered several of that. And then we have this question about these...
basically... I got caught up with
done. Okay.
Yeah.
Okay, so then we got you developing this other platform at Willow Garage that was in what was the name again?
The PlatformBot?
Yeah. PlatformBot.
It was not a very original name, right? It was a platform that was a robot and you could put different things on top of it. It was just sort of
okay. So that's the PlatformBot. Then from that we got the Unbounded Robot, the UR1. But then so Unbounded Robotics has to close, and then next thing is in your life is to Fetch. So you were at Fetch. You were working for Fetch as a CTO.
Yeah.
And what are you proud of your time at Fetch? Or what were you developing in those terms?
So we did a lot of stuff with Fetch. We managed to keep sort of the team that had been at Unbounded together. And so we could go and we kind of got brought in to do Fetch. And we built obviously the Fetch mobile manipulator and the Freight mobile robot, which is not got the torso and the arm and the head on it, but still has the mobile just driving around part. And those robots are really nice. We released those, early on. We had a research product based around those, right? Where you could buy, a mobile manipulator that was significantly cheaper than a PR2 still. I think when you ask, what was I really proud of there? Certainly when we launched those as products, I got feedback very quickly from professors who were like, this is awesome.
Wow.
Like the out-of-box experience was just so much better than even the PR2. Because when the PR2 shipped, we didn't really have things like Move It available, and certainly not configured for it. And it was always kind of this like, how do you do things with this robot? With a Fetch, you could basically, we had a gazebo simulation, or you could do it on the real robot, where basically, if you put a little cube on the table in front of it, it would reach out and pick it up. And in the gazebo simulation, it would actually drive over to the table where it knew where that cube was, pick it up, and move it to another table. The fact that like the software was at that point, it was a really cool set of applications that really demonstrated, I think, the power of ROS. And this is 2015, right? It's taken some time, but by 2015, ROS has gotten to a point where like, hey, we've got these higher level applications like Nav and Move It that are pretty reliable, and we've built applications on top of those that you can actually see the robot do things and not have to understand every little aspect of it, and then you can basically take that as building blocks to go add your own, perception algorithms or your own motion planning, but you didn't have to do everything to build this demo. And so I think that was, personally one of my favorite parts of it was just that great demo. And then obviously, Fetch is in the logistics market and, definitely more focused on the freight robots, and they've built bigger versions of the freight robots for bigger payload. All of that's still, very cool running ROS. I gave some talks along the way at actually here at ROSCon in past years on, our build systems that we released and, on the, how to, I gave a ROSCon talk a couple of years ago about how to accelerate your robotic startup using ROS, right? Sort of our lessons learned about, using ROS and building on it and commercializing things. And it's really cool to see that sort of take off a lot as well in the ROS community. You're seeing more and more startups here that are building commercial applications, which is still incredibly difficult because like robotics is it's very challenging, right? Like it's sort of all encompassing. The applications people want to see out of robots are really demanding. And so it's definitely cool to see that, moving along.
Okay. And what do you think about that? Now that you mentioned about these creating products, how to accelerate your startup, still a lot of people that they think that they can do it faster without using ROS. So that's one of the things that it surprised me. That I can understand other motivations, but thinking about that you can do a startup faster without using ROS. So what do you think about that?
So I think it depends on a couple of things. If you're able to leverage a lot of, so if you're doing a mobile robot or an arm or something like that, I think ROS brings a lot of stuff in. If you're doing like drones, the toolkit's not really there. And so I believe that if you're doing a drone startup, ROS may not be the right tool, right? It's not the right tool for everything, for everybody, right? That said, if you're doing a mobile robot that's navigating around,
that's the case. That
building that quick demo to be able to show to investors, to get, even just, not even just showing to investors, but showing to customers, it may not be the final robust solution, but you can show them that it's real enough and you can get early feedback and iterating quickly is one of the most important things in a startup. And so I think that's really important. I think the other part is eventually everybody probably throws away the nav stack and they throw away large portions of Move It. But the tools like RViz are really, really useful and would take a lot of effort to actually develop on your own.
Yes, exactly. And debug and find all the errors and then, I do agree with you. I do agree. So now you have been developing all those robots, the Fetch robot and some variations of it there. You mentioned something before we go to your new situation. You mentioned about the experience when getting the people getting the Fetch product.
Yep.
So this is something that when you mentioned that, then I understood the feeling, because one thing is to have one robot in your lab that is working and is doing, it does very well. This is one thing, but convert this into a product that you ship to the client. The client opens the box and then it works. That is something very difficult. It's another level. And that's what you were expressing.
Shipping robot hardware and software that just works out of the box is still challenging today. And I think when you get it right and you get that out there, there's definitely, I think, that's definitely this kind of thing where you take a lot of pride in, right? It's not something a lot of companies have done well. A lot of companies have put robots out there that are not really ready for prime time and aren't able to deliver what they claim they're going to deliver. I've always been really big on sort of under promise and over deliver. Like that's really important, I think, to just keep both that brand and that product positive in the minds of the people who are buying it and the people who are looking at it.
Yes, definitely. Just wanted to point this for all the listeners, because when I know, because it happened to me also, so that you think that you have it because it's working on your side. Then when you have that, please, if you are there thinking about building a robotics company, I hope that you are, listeners there, please bear in mind that you have to allocate a lot of time and effort after you have it done in your lab. So it works in your lab, even if it is robust and so on. But then there is another process from that is going into product. And that's a phase that you have to do. Otherwise, you will burn your company. So nobody will trust you, because it's a lot of effort from the lab into the product. So just wanted to point that. Because I think it's a lesson for the guys. Then let's go. So you were working at Fetch, and then now I know that you have, once you left Fetch, then you have done some other stuff and around there. But the interesting thing, that the one that brings you here to the ROSCon today, is because you have founded a new company that is called Botnuvo. What is Botnuvo?
So Botnuvo is designing and manufacturing robots for researchers, educators, and developers, right? There's a lot of companies out there today that are building robots for sort of end users in logistics, right? They're trying to build, the whole thing out. And that's great. That's a really big business. Most of them are, big venture-backed companies. I've done the venture-backed thing a few times. I'm interested in trying something a little bit different. I grew up in sort of the small business background and whatnot. So Botnuvo is a family-owned small business building robots. Obviously, my background helps make that possible and whatnot. But we're sort of going into the market where I think there's a lot of sort of TurtleBot level things where there's a robot that's like, it's really cheap. It kind of does some things, but like trying to learn like robot navigation on a TurtleBot that doesn't have a laser sometimes, or doesn't have much of a laser if you're in a bigger environment. You spend more time, I think, fighting your platform, right? You don't have enough processing power, you don't have enough laser. And then at the other end of the spectrum, you've sort of got, you can buy, commercial platforms that they're big, they're heavy, they're potentially dangerous because of those things, but they're just a logistics nightmare to move around. And they are commercial platforms that, were developed using a bunch of venture capital money. So they're pretty locked down. They may have ROS drivers on them, but those ROS drivers are locked to a very specific version of ROS, and you're very much at the mercy of the vendor. I've always been really big on open source, and so that is one of our things, is that everything that's running on the computer, the drivers, all of the applications on top of it, it's all open source, and it's not sort of open source that's hidden behind some firewall where you got to log in and whatnot. Everything as we release it out is going to be just public right on the GitHub, right?
Including the schematics of your robot?
Not so the hardware level is not
Okay.
everything that's on the computer.
Fine.
And basically that means you can, if you want to change your operating system, if you want to change which version of ROS you're on, you can fully do that, right? We're going to have, all the documented aspects so that you could, retune the PID within certain limits and whatnot, right? So if you put extra load on, you can actually adjust it so that it's still, got great response times with your added loads. And a lot of people ask, well, why don't you make the hardware open source and whatnot? To us, a big part of that is that, for sort of reliability and warranty service, if we let people sort of go in and change how, say the low-level motor controls working and how it's like running electrical signals, you're going to start to burn things up and whatnot, right? And so, all of that low-level protection of making sure that your robot continues to work is sort of done at the firmware level for us.
I see. It's part of your service.
Right. But certainly the API of how you communicate with those boards, that's all open. And so, even if you say, hey, look, I don't even want to use ROS, right? Our core driver library is just pure CMake, C++ with pure CMake built around it. We use the same library in ROS 1 and ROS 2, and if you want to move it into a different project, you could do that too. And so it really is meant for people who want to dig into working with the robot, but also they want that out-of-box experience. So I think you were going to ask about applications and whatnot. I'm just going to jump right into that.
Sure.
I'm one of the maintainers of the ROS nav stack, right, in ROS 1. Obviously, we have a config for ROS navigation, so that's sort of out of the box.
So exactly. So you buy the robot and then it's all available.
Right. So when you pull it out of the box, you basically plug in a keyboard and a mouse a keyboard and a screen, right? And hook it up to your network, right? Because it's just so much easier to do it by the GUIs on the screen. Once you've got it on your network, you can SSH into it at that point. Start Slam Cardo, go around and build a map. Load your map over, fire up nav, and like RViz, you're just clicking and sending the robot around. You can do it programmatically as well. The sort of, hey, within 30 minutes of unpacking the robot, you're autonomously navigating around your facility.
I see.
That's huge, right? And now you can go and build off of on top of that.
Applications on top.
Right.
I see. Okay, so then in terms of applications that you ship with your robot, that would be the navigation system of the robot that is based also on ROS.
Yep.
Of course.
Yeah, the ROS navigation stack, which is used on a number of robots out there. But we have the added expertise that, being one of the maintainers, I really understand the system very well to give you a great tuning on the nav stack.
You are still
yes, I am still one of myself and David Liu are the main maintainers of that.
David Liu. Okay, and so now that was not a question on the list that I have in mind, but now that you mentioned that, so what is the status of the nav stack? In terms of, do you have something in the future that could be interesting for navigation? Like, for example, adding support to very large maps. That's a problem that we have in navigation, lifelong mapping or something like that.
So let me take those as two separate questions. So I'm actually going to talk about the lifelong mapping. So that's definitely more SLAM, which is typically a separate packet. Like the nav stack itself doesn't actually have map building, right? So Slam Cardo does that. I know, the Slam toolbox, right, is trying to get towards lifelong mapping.
That's right.
It's not a project that I'm working on, but I'm following closely. I think in the ROS 1 world, there probably aren't going to be a huge number of changes to the navigation stack, just because ROS 1 is sort of getting to end of life, right?
I see.
I know there's a lot of work going on. I've been a little involved, not so much from the coding level, but sort of advising and whatnot right now. The navigation in ROS 2 that Intel's working on, we're certainly going to be having a configuration for that to run in your ROS 2 version. That's a little bit, the ROS 1's ready right now. The ROS 2's still kind of coming up. There's various dependencies that haven't been ported over. So, we're doing quite a bit of work diving into ROS 2 right now to get everything up to those levels to be ready for the robot. But it's not something that's shipping on the robot today, but will be very shortly. Listeners who are listening to this in 2020, we have the ROS 2 support out by then.
Great. Yes, by the day that we publish the podcast, you mean?
I'm thinking, the people who listen to it, right when it gets published, it's probably not there yet. Okay. But I imagine that people are going to stumble upon this in the future and check it out. We probably have that all up and ready to go by then.
Okay, so very good mind that you are thinking about the future, because we are thinking just about the moment right now, but maybe you are listening to this podcast and it's 2030 or something.
Because people come into ROS at different times, and so new ROS users today are going to discover things later that we've all seen a long time ago, but they're looking at it going like, hey, this is new to me still. Try and keep it relevant. Right?
Okay, very good. Very good business mind there. Very good. And then if you are from 2013, then check the Botnuvo robot working on ROS 24. ROS version 24.
ROS 2.
No, but I mean
ROS 24. I don't know. It's in a lot of ways it's kind of like the Python 3 transition, right? It takes a very long time, particularly when low-level APIs are just completely rewritten.
Okay.
So
then.
So I think ROS 2 will be around for a while. It'll probably evolve a lot over time, but it's going to be around for a while.
Okay, then if you are in 2030, in the year 2030, then look for the first non-alpha, non-beta version of ROS 2. Then that will be more close. Okay, just a joke. Okay, please don't get angry. Just making jokes here. Okay, so then what is the kind of robot that you have built at Botnuvo? Can you provide us more specification? For example, the name and what it does, what it contains?
So our first product is a mobile base, right? A mobile platform called Velocity. Okay. And so our tagline on it is like accelerate your research, right? So if you're doing education, if you're doing research, right? The idea is that this is going to accelerate what you're trying to do, right? Out of the box, you've got so much that's well developed and ready to go. All of the standard ROS things are there. The documentation's there, so that you're not fighting your robot, right? Like you want to be basically diving right in and working on that thing that you actually want to work on, whether it's learning how navigation works or learning how mapping works, or it's developing new mapping algorithms, or one of the things I think is starting to get really starting to become a research area again is this sort of fleet control and whatnot, right? Because it's huge in the commercial logistics market now. Yes. Anytime that there's sort of like this sudden application available, researchers are looking and go, wow, like they still haven't really figured this out. There's not a lot published. Like we can really dig into this as well. And certainly with the lower cost on the robot, like you can actually afford fleets because they're not, this $100,000 mobile robot or the $60,000 mobile robot.
Yeah, that's a lot. And then which sensors does it have, your robot? And which side? So we
currently have two configurations. Both configurations ship with an Intel PC, right? So you're not ROS, for as developed as it is these days, it really prefers to be on sort of Ubuntu as an operating system and really be on an Intel processor. You can run ARM, but again, you're fighting against the tide.
So you're putting a lot of more
problems. Intel processor in there. You've got a lot of compute power available for those crazy nav algorithms or SLAM algorithms that you're going to develop. All of our robots ship with a laser. On our lower cost model, it's a 4-meter Hikoyu laser. Okay. So great for a classroom. You've got more than enough range. You can learn all of your algorithms on that. Our higher end platform has a 25-meter laser from SICK. And so now this is the sort of thing that you could drive around this giant convention hall and build a map without any problem, right? And navigate around. And, if you're prototyping some application in, say, a giant warehouse or whatnot, like the laser's not right. It's the same laser that honestly is in, I think, most commercial robots today, like the smaller AMRs. They're all running this amazing 25-meter laser.
Because for indoor is more than enough.
Yes.
Another thing is we talk in the outdoor, but that's not the target at present.
No, we're definitely an indoor robot. We don't have any IP67 ratings or anything on that. That just drives cost up a lot on things.
Yes, I understand. Yeah. Then if I have understood correctly, then your platform will be so you are targeting a certain sector in the robotics, let's say, line, starting, for example, let's say Turntable 3. Okay, so we have it's a small robot that you can have on your table, and you can practice many things about ROS. Then we have Turntable 2 that is bigger, and so it can go into one space like this conference also, with more problems, but it can do it. Then I would say that is your platform that is more, let's say, more robust, has more payload, so it can carry more stuff and move faster, and so and then we'll have then the bigger robots like the Fetch and Freight and so on. So that's
so
the
it's sort of
sector that you're targeting?
Yes, definitely. It's sort of, it's a little bit smaller, so it's a lot more manageable, especially, in your lab. The whole robot's under 30 pounds, 15 kilograms, right? And so, it's the sort of thing, I actually brought the robot here in a Pelican case as checked luggage, right? You're not going to do that with something that needs to ship freight, right?
And what did you do with the batteries? Because that's
so I actually pulled the batteries out, and we actually had batteries shipped in separately that were purchased locally and whatnot. They're a very standard battery, so it's actually very easy to do. And so we actually sort of did the go on Alibaba and get batteries shipped directly here, because hey, we're pretty close to China. It was very easy to get them delivered.
That's a very good idea.
Yeah,
exactly.
So locally procured, and when we're done with this podcast, that's actually my next thing, is to go put the batteries in, since like I said, I got here back 5 a.m. this morning.
Okay, I will, by the way, I will put some pictures. I will take some pictures of Michael and also his platform, and then I will put it on the podcast, on the notes, on the show notes, so people can have a look and get an idea of the physical, how it looks, and then sizes and so on. Great. And then, what's the name of the robot? You did
Velocity. I did say that. Let me talk about accelerating your research, right?
Velocity. Yeah. So that's
Velocity.
That's it. And then you mentioned that it's natively programmable in ROS, so you don't need anything else. You have you have indicated that.
Yeah, right out of the box.
And then also, but the navigation. I was here asking about the auto charging thing. Is that possible to be done even if you don't ship it? Is it possible?
So we do have a charge dock right now. That's it's still a little bit in development, but it'll be ready very shortly.
Okay.
And that will come with an auto, sort of an auto docking routine, so that you can get that continuous runtime out of the robot, right?
Okay, so if I buy one of your robots right now, then the hardware
is already ready to go.
Okay.
Yeah.
No, I'm telling you that because the charging, so it requires a specific locations to be open to make the connection with the. So you didn't think about this beforehand, then modifying.
No. That's definitely been from the get go. Right.
Okay. Okay, and then just by curiosity, it's not very important, but by curiosity is about which ROS 1 distribution it is working.
So we're definitely at this point, it's going to be on melodic initially, right? Because Kinetic is more than halfway to end of life.
Yes.
It doesn't make a lot of sense to ship something new on Kinetic.
That is right, but a lot of people are doing it.
Yeah, but I think that's because the robots that they're on are
older,
right? Yeah. When people are buying, people who have a robot in their lab that runs Kinetic and doesn't support melodic yet, that's what they're going to stick with. I know certainly we're going to end up with Noetic support shortly. Just because of the whole aspect of Python, Noetic will be Python 3, and it's kind of the last ROS release that's slated right now. So I expect that's the one that people will be on for a while. Certainly, we're doing work with ROS 2 on dashing right now, but Eloquent will probably be the first one that actually ships to customers, since that's just around the corner.
Okay, the new one.
It's
when is it going to be? I think it's by the end of the year.
It's Yeah, I believe like the feature freeze for low-level stuff has just gone by, or is just about to go by while we're here at ROSCon, pretty much. And then everything else is sort of, ready for testing and whatnot in November. So it's coming up fast.
Oh yes, they are releasing ROS 2 distributions.
Twice a year.
Exactly. That's
which is what we used to do with ROS 1 when it was under active development. So there's definitely precedent there for it.
We had also Julie Foot from the Open Robotics at the podcast, and he was explaining to us exactly that. So why so many distributions? So why it was faster at the beginning of the ROS. Then they changed to 1 year, and now it's about 2 years or 1 year and a half.
Yeah,
2 years.
The melodic to noetic is basically 2 years. It basically just matches the Ubuntu LTSs, the long-term support releases.
Yeah, so now ROS 2 is doing the same thing for that. Then, do you have a Git where people can download a simulation of the robot or any other software? They can start playing with it and doing something.
So we do have the Botnuvo user on GitHub is our organization.
Okay.
So github.com/Botnuvo. The gazebo is not up there quite yet. It will be up there very shortly, probably right after I get done with iROS. We haven't gotten the final touches on it and gotten it ready for the release. So we're actually going to be, that'll be launching some point in November, and we'll also end up as Debians on the ROS build farm as well. So, the gazebo simulation will be coming out very shortly.
Very shortly. Okay, so so that's a very important point about the simulation, because then people can actually
go in
try
stuff out ahead of time. Yep.
Exactly.
And certainly, once they buy a robot, they can sort of test in simulation before they go to the real robot. Definitely helpful when you've got a very active lab and a limited number of robots.
Exactly. And then what are the future plans for Botnuvo? So you are releasing this. Can you tell us something about your future plans? Maybe other platforms, maybe built on top of this one?
So this is definitely a stepping off point for I eventually see sort of a whole line of indoor robots for research labs. Obviously, I think you were wondering about mobile manipulation a little bit, since I obviously have done a lot of that in my background. That's definitely a direction we're going.
Is it? Oh, wow, interesting.
I think with everything that we do, it's the same sort of style of there's not a lot of sense in putting out another, $80,000 mobile manipulator, right? And so, but it obviously with Unbounded and other things that I've worked on in the past, this sort of $30,000 mobile manipulator is definitely something the market I think has really been desiring for a while, and it just hasn't happened.
Yes, that's right.
And so, we're definitely doing work on that area. I don't obviously have a timeline of like when that is, because to actually do that requires a certain number of engineering breakthroughs in like how things are built and whatnot. But I think, look around in the future and we'll
just wanted to have a vision of what is the direction that you're moving.
And certainly I think with even just the velocity base as it is today has mount points on the top of the robot, and so we'll have a number of accessories for that coming out in early next year.
And do you have in the velocity robot, do you have a kind of pad where you can connect extra devices, like for example, maybe we can buy an arm from another company and then attach there in those holes that you have on top.
Right.
But then how do we connect to the batteries and how to the control?
So right on the top of the robot exposed is certainly the USB and the HDMI, which can also be used for other things. There's also, and you'll see on the robot when I show you it later, there's another like sort of plugged port on the side that is right over our main power control board. And so we do actually have 24 volts always on, a switch 24 volts, switch 12 volts, and a couple of extra, primarily RS-485 buses. And so those are definitely future-proofing for things like arms, or even a pan-tilt head, or things along those lines.
And maybe some extra USB, for example, for connecting a cloud
certainly,
camera.
There's plenty of extra USB inside that can be routed out. So not necessarily a bunch of all those little circular connectors and whatnot are really expensive to have. A lot of just like every type of connector coming out the top. So we definitely take more of the approach of there's an area to route cabling through. You put in just what cabling you end up needing.
Okay.
Yeah.
Okay. So, well, I think that we covered a lot here. So, Michael, thank you very much for coming to the podcast. I wish you the best of luck, and that you sell a lot of robots, because I like very much when I see growing the whole ROS community. That people take the chances, take the risks to build a company that is based on ROS and providing products. So then I wish you the best. Thank you very much for coming to the podcast, Michael.
Thanks for having me.
And see you around. Yes. I will put, by the way, some links on the show notes for your GitHub, for your webpage, the people that is interested there. Just look at the show notes and you will have everything in there.
Great.
Okay, and that's all for today, ROS developers there. Please leave us a review on iTunes telling us what do you think about the podcast and what you would like to have in the future. So how can we improve? And because this is very useful for us, and we can improve actually the podcast. In case that you would like us to interview some specific person, you can say that also there. So before I run out of voice today here, then let me thank you very much for your 5 stars in iTunes, and see you next week with a new lesson from the expert. Until then, keep pushing your ROS learning.
Developers podcast.